This is an introduction to chemistry prepared by Felisa Ricketts. It's time to meet your teacher. Now, Felisa Ricketts is a chemistry, biology, physics, and integrated science educator. She's an educational specialist who is passionate about education and youth empowerment. She's also the founder and managing director of Western STEM Academy. So welcome to all chemistry students. Today we'll be taking you through chemistry. We'll be giving you an overall introduction to chemistry. You'll be learning what is chemistry, as well as the first part of the CSEC syllabus will be covered in this video. Thank you so much, and I hope you enjoy. If you have any questions, please comment in the comment section and we'll definitely get back to you. All right, students? Now, the first thing we need to know is, what is chemistry? Have you ever thought about what is chemistry? Why am I even studying chemistry? Why did I choose chemistry as a subject? No. The first thing you need to know is that chemistry is the study of matter. Now, what is matter? Matter is anything that has mass and takes up space. There are over 4 states of matter, but at this level, we are actually only focusing on 3 main states. These 3 main states are solid, liquid, and gas. I want you to take a minute. Think about examples of solids that you might know, examples of liquids that you might know, and examples of gases that you might know, and I want you to write them down in your notes. All right, go ahead. No, you've written down your examples. Feel free to share your examples as well of solids, liquids, and gases. Now, as we said earlier, there are actually over 4 states of matter. In all, some scientists have come up with even 15 states of matter. But our primary focus in this lesson or this section of the syllabus is under 3 states of matter: solids, liquids, and gases. But just for reference sake, you might wonder, what are the others? So I've placed 4 more here for you to follow. So we have ionized plasma, we have plasma, which is quark-gluon plasma, Bose-Einstein condensate, and we also have fermionic condensate. So these are the other states of matter, but we're only focusing on solids, liquids, and gases. That's why I've highlighted those. All right, now states of matter. The physical states. If you should look at a solid, the particles, you're not going to see the particles just like that, but the particles of the solid, they're actually arranged close together. So you're seeing that the solid particles are arranged very close to each other. Now, the molecules that make up a solid are arranged in a regular repeating pattern. They are held firmly in place, but can vibrate within a limited area. So solids, actually, they're able to move, but that's by vibration. And you know from physics lessons that vibration is what produces sound. So if I should knock my table, you're hearing sound, and that sound is as a result of the vibration of the particles. Now we also have liquids. Now liquids, do you know any examples of liquids? Yes, I bet you just said water, because that's the first one that usually comes to our mind, but we have other liquids, all right? Mercury is a liquid, and that's a very unique liquid, and you're going to know why in our next video. Now, the molecules that make up a liquid flow easily around one another. They are kept from flying apart by attractive forces between them. Liquids assume the shape of their containers. Now, if you take a liquid, meaning your water in your water bottle, that liquid, and you pour the liquid in to, let's say, a bowl, you'll realize that the shape will differ because liquids take the shape of their container. All right. We also have gases. Now, the molecules that make up a gas fly in all directions at great speeds. They're so far apart that the attractive forces between them are insignificant. I'm sure you've blown up a balloon before and you just release the gas and it just flies out. So that's how gases are. Now, we're just mentioning plasma so you can be aware of what it is. Plasma, at the very high temperatures of stars, atoms lose their electrons. The mixture of electrons and a nuclei that results is the plasma state of matter. So we're talking about charged particles when we talk about plasma, but we won't be going deep into that. The focus is on solid, liquid, and gas at this stage. All right, students? Now, states of matter. Here we have a table on how the particles in the three main states of matter are arranged, how they move, as well as diagrams to represent them. Now for solids, the particles are arranged close together. In liquids, they're also close together, but there is a little space between them, or there are spaces between them. And for gases, the particles are arranged far apart. Solids are in a regular repeating pattern. Liquid is in a random arrangement. Gases are also randomly arranged. Now, movement of particles. For solids, as we said earlier, they vibrate on the spot, vibration. For liquids, they move around each other. And for gases, they move quickly in all directions. So here we have the diagrams of how the particles are arranged and basically showing you how they would move if they were supposed to move right here. Now I want you to list examples of each state of matter in the boxes provided. Earlier you did it, so I want you to place these in the boxes here. List some solids, list liquids, and list gases. I want you to have at least 3 examples of each state of matter. Now we're at changing states. Now I'm sure that probably, just maybe, we've had some ice or a frozen drink. We took it from the refrigerator. We want it well cold, so we put it in the refrigerator earlier. But then we took it out of the refrigerator and we probably left it on the table. What do you think is going to happen if you should come back to that a day later or even some hours later? Let's say you get a nice juicy phone call or a nice WhatsApp message and you put down your ice on the table. What do you think is gonna happen if that conversation took 4 hours and you're just coming back? What's gonna happen? Yes, the ice will melt. So matter does not only exist in one state, but a substance that is in one state is able to change from one state to another. For example, our ice, it can change to water by melting. And if you should add heat to that water, meaning you put it on the stove and you turn it on, then what's gonna happen is that it will eventually boil and evaporate. And then that will form steam or water vapor. So we have changed from a liquid state to a gaseous state. Now, you turn off the stove and you leave the steam there. What's gonna happen is that the gas will cool by a process of condensation. So you're removing heat. So for the bottom arrows, you're removing heat. For the top arrows, you're adding heat. Now the condensation will happen and now that gas will now be a liquid. And if you should put it back into your refrigerator, then it's going to freeze. So we've just done some changing states. Now there's a special name that we give for substances or that we give to the process by which a substance changes from a solid to a gas without passing through a liquid state. And that process is sublimation. Sublimation is a process by which a substance moves from or changes from a solid state to a gaseous state without passing through the liquid state. Examples of substances that sublime would be your dry ice, camphor ball, among other things. I want you to research 4 more substances that sublime. So research 4 more substances. So you need to know the names of at least 6. I gave you 2, so research 4 more substances that sublime. In addition to that, I want you to define the following. What is melting? What is freezing? What is evaporation and condensation? What is sublimation? So we just told you what is sublimation. So you're going to make notes now of these important terms. You can pause the video here so you can go ahead and do your background research as well as record your information. Now we're at heating and cooling curve. Now a heating curve is a plot of the temperature of substance versus the heat added to the substance. Now here we have, starting from point A, we have ice. So this is definitely the solid state. We're moving from a solid, and now between B to C, we have ice and liquid water. So melting is now taking place. Now from C, we have the liquid water, which is liquid now in this process. Now by the time we reach to D, between D there, we're going to have liquid water and vapor, which is vaporization at DE, that red line there. Now we are at point E, and then we go from E to F. Between right there, we have our water vapor. The graph basically shows the response of the different phases to added heat or heat capacity. That's the topic that we cover intently in physics, and the heat needed for phase transitions, which could be melting and boiling. So what I want you to do is to identify the melting point on this cooling curve. So I want you to identify the melting point, and I also want you to identify the boiling point. All right, so now we're ready for the particulate theory of matter. When we hear particulate, we hear one particular word, and that word is particles. Now, the particulate theory of matter states that matter is made up of tiny particles. These particles are always in motion. Now, all pure substances are made of their own kind of particle. All particles are moving. Particles at higher temperatures move faster than those at lower temperatures, and particles are attracted to each other. So these are the 5 main principles of the particulate theory of matter. Essentially, what we mean is that matter is made up of particles, and these particles are always in motion. This is essentially what the particulate theory of matter states. Now, there are 3 main evidences that scientists use to support the particulate theory of matter. The first one is diffusion. The second one is osmosis, and the third one is Brownian motion. These 3 theories prove, or these 3 evidences prove the particulate theory of matter to be true. Now, what is diffusion? What are we even talking about when we mention diffusion? Now, diffusion is the movement of particles from an area of high concentration to an area of low concentration until all the particles are evenly distributed. Now, in diffusion happens in everyday life. Diffusion happen at home when you're making your tea, and you're using your tea bag. That is diffusion. You're making Milo, that's diffusion. you're also making your syrup. That's diffusion, because the particles are moving from a high concentration, as you're seeing in this diagram, to an area of low concentration until they're evenly distributed throughout the liquid or throughout the gas. Now, diffusion occurs in fluids. Fluids are basically things that flow, whether it's a liquid or a gas. All right. Diffusion also happens when somebody sprays their perfume and you're able to smell it. That's diffusion. On the right, you're seeing somebody with an inhaler. Diffusion happening there. All right. Now, examples of diffusion. No, this is my favorite one. Sometimes we're passing KFC and we really didn't plan to buy any chicken. But then this wonderful theory of diffusion allows the particles from inside of the kitchen in the KFC to diffuse outside, and now we're able to smell it at a distance. And guess what? We take our time and we go closer and closer, and before we know it, we're walking through the door with a bucket of chicken. Never planned, but here we are with a bucket of chicken because of diffusion. So that's what diffusion is. You can go ahead and write more examples of diffusions below. All right. Now, osmosis. That's another theory that proves the particulate theory of matter. Osmosis is the net movement of water molecules through the cell membrane from an area of higher to an area of lower water potential. So osmosis is essentially the movement of water molecules or solvent molecules from an area of high concentration to an area of low concentration through a selectively permeable membrane. So the membrane has to be selectively permeable. Now, osmosis actually only happens in living cells, so there needs to be a cell membrane. Now, there are different examples of osmosis. Have you ever gone to the beach and you realize when you come out of the water, your hand, it looks a bit shriveled? That's osmosis. We have more examples. On Sunday, Jamaicans, we love to soak our red peas. That's osmosis, because we have water molecules moving from outside through the membrane of the pea, going inside of it. Now that water, it has moved from outside to inside because we have a higher concentration outside than inside. And now what happened is that this pea will actually, it will get a little bigger, so it's gonna get swollen. So it's gonna get swollen, and then it will also soften the inside of the pea. So that's the essence of why we even soak it, soften it. So that's osmosis happening there. Now sometimes we soak it so much that sometimes you realize it bursts. So that's exactly what happened in osmosis. Osmosis happens inside of our bodies, that our cells get water, but there is a whole process there to ensure that we don't have any bursting of our cells, as we were seeing with the pea right here, because imagine all your cells bursting because they took in too much water. So there is another process in biology that we'll be exploring in that session. All right. We also have osmosis with our Irish potato. We also have osmosis renal treatment and slugs. Now, many times we throw some salt on the slug to kill the slug. That's osmosis, because what's happening is that the water inside of the slug will now come out. So it's going to move from the higher concentration, which is definitely inside of the slug, to outside. So you're basically taking the water out of the slug, or even the frogs when you do that. Now, there is another way how we use osmosis, quite interesting. Some of you at home, you have a fruit or you have a vegetable and you put a little salt on it for it to bring out some more flavor. That's definitely osmosis. The process of how your food is actually able to be cooked, when you put your yam and all of that, it's actually osmosis, because you have water from the higher concentration going to a lower concentration. So that's osmosis. So what you're realizing, students, is that osmosis happens in everyday life. This is a real process that happens, and all of these processes prove that matter is actually made up of particles, and these particles can move. So this is what these three theories do. Now, Brownian motion is the final one. Before I give you what the definition is, I'll show you what an example. Now, you wake up in the morning and there is a beam of light coming into your house. But then inside of that beam of light, you're seeing some particles moving, and you're wondering, what's that? Is that an animal moving inside of my house? Are those animals? Are those bugs? But the truth is, it's just particles bombarding in air, and you're able to see them because of the beam of light shining on them. So Brownian motion was named after the botanist Robert Brown. He was the first to study, well, to really discover Brownian motion. Brownian motion is a random movement of microscopic particles suspended in a liquid or gas caused by collisions with molecules of the surrounding medium. So it's the random haphazard movement of particles as they collide in either air or water. It's the random haphazard movement of particles as they collide in air or water. Now, it was named after Robert Brown, as we said earlier. The simple demonstration of Einstein's explanation for Brownian motion shows little particles batting about a more massive one. All right? Now, we're going to be showing you now some experiments and lab support. Now, experiments that we usually do in the laboratory to prove diffusion, first of all, we normally use potassium permanganate and water, and we observe diffusion in hot water and in cold water. For osmosis, we usually use the Irish potato, salt, and water. We observe a solution with just water only, just water, well, not a solution, but we observe water only along with the Irish potato. We watch what happened with that, as well as sometimes we put salt in the water to observe what happened with that. Now, the idea behind this is that when you put just the water and you put the potato into that container with just the water, that potato, it will take in the water, so that will actually get bigger or it will be swollen. But the ones that have the salt water, that is supposed to lose water. So the water is going to move from inside of the potato to the outside, and it will actually get smaller or shriveled, for want of a better word. And that's essentially what happened in real life when you're washing and you look at your fingertips and you realize that they look all different. Or even sometimes you go to the beach and guess what? You just ate a big bowl of KFC because you were on your way to the beach. And then when you go into the water and you swim for a while, you realize that when you come out, you're hungry versus when you go to the river when that's fresh water. That's all osmosis, real life examples. Now, to summarize what we've just learned, matter is everywhere, and chemistry is the study of matter. So chemistry is essential to our everyday life because we're studying matter, and matter is everything around us. Matter, there are three states of matter that we are studying at this level: solids, liquids, and gases. Now, substances do not just exist in one state, but they're able to move from different states by adding heat or by removing heat. So that's essentially what happens when we're changing state. Now, the particulate theory of matter states that matter is made up of particles, and these particles are always in motion. There are three main evidences to support this: diffusion, osmosis, and Brownian motion. Now, the examples, you can go back into the video to find out examples as well as the definition for diffusion, osmosis, and Brownian motion. There will be some summary questions posted below because I want to ensure that you have definitely grasped, mastered this topic or this concept, this introduction to chemistry. Feel free to go back, feel free to download the video, ask me any questions that you might want to ask, and I'll definitely be providing you an answer. It's my pleasure sharing with you. My name is Felisa Ricketts, and I am your chemistry teacher. Have a wonderful day, and thank you so much for watching.